Hello, and welcome to. Sorry.
Welcome, everyone, and thank you for joining us. Please enter your questions for the presenters in the questions panel of your GoToWebinar panel. And at the end of the presentation, we will get to them in the order received. This session will be recorded, and the slides will be available on our website shortly after the live event. Now, I'll pass it over to our presenters, Floyd Smith, Director of Content Marketing, and Faisal Memon, Product Marketing.
Hello, and welcome to our webinar, Access Management and Security Controls. Our presenters today are myself, Floyd Smith, Director of Content Marketing here at NGINX, and Faisal Memon, Product Marketing Manager at NGINX. We each have a fair amount of experience in Silicon Valley and to a certain extent worldwide, and have each been here at NGINX for several years. Our agenda today includes introducing NGINX, which I'll cover, IP access control lists, using SSL TLS with NGINX, and that includes the free Let's Encrypt certificates, rate limiting, connection limiting, and bandwidth limiting, basic, sub-request, and JOT authentication, and a summary and Q&A. I'll be doing the initial section, and Faisal and I will do the last part together. He'll be delivering the core of the webinar. So NGINX started with one person with a big concern and a big idea. And Igor Sisoyev says, when I started NGINX, I focused on a very specific problem, how to handle more customers per a single server. At the time, this was known as the C10K problem. It was a great barrier in computing and supporting online sites, and Igor solved it. And that's the NGINX that we've all come to know and love. Now there's a company. The open source was released in 2003 and steadily made its way around the world. The company was founded in 2011 and is steadily making its way around the world. NGINX Plus, the commercial version of the NGINX open source software, was released in 2013. The company is VC backed by leaders in enterprise software. We have offices in SF, London, Cork, Singapore, and Moscow, and a few outposts elsewhere as well. More than 1,100 commercial customers and more than 200 employees. 55% of the top 100,000 most visited websites use NGINX, which is an amazing number. And adoption is a little backwards from new technology. A lot of times people try technology out in smaller sites, and it's hard to get it onto bigger sites because they're busy and they only use software they really trust. But adoption of NGINX is the reverse of that. The larger the website, the more likely that it runs NGINX. And the reason is that large websites have a problem with handling lots and lots of traffic. And the best way in the world to support lots and lots of traffic is using NGINX. That can happen in two basic different ways. The first, and the rightmost of the ends on this chart, is using NGINX as a web server. So if you're running an Apache or IIT web server and it starts to get too busy, those web servers use more memory with each new connection. So as you get more and more users up close to your limit, performance asymptotically slows. That means that each new user gets handled worse than the one before. And this puts you down a rabbit hole that is very hard to get out of. It's very easy for the website to hang or crash, especially on days when you get a lot of publicity or there's a lot of need out there for you, which of course are the worst days to crash. If you replace your web server with NGINX, suddenly you break the C10K barrier and you can handle many, many more connections with much more graceful degradation of performance if you get close to the much higher limit that NGINX has. And then when that's even not enough, you can use NGINX as a reverse proxy in front of application servers. This instantly offloads the internet traffic onto the NGINX reverse proxy, which can handle it well, and you can do a lot of things there, including the security steps that we'll be talking about today. You can also use the reverse proxy server as a cache for static content, as a cache for dynamic content, and is the load balancer for multiple application servers. So you can put NGINX in front without changing a thing on your application servers, which is kind of a secret that is not so secret anymore, but people have used for years and years to save flailing websites. There are some prerequisites for using the information that we'll be talking about today. And this is having either NGINX open source or NGINX Plus installed from an official repo. The repo for OSS is listed here along with the repo for NGINX Plus. There's also a free trial version of NGINX Plus if you want to try with that. And you need a basic knowledge of NGINX configuration. If you don't have that, then poking around on our blog can actually give you a fairly good idea, and the docs on nginx.org as well. And I'll now turn it over to Faisal.
All right, thanks, Floyd. And with the rest of this webinar, we're just going to focus on the security features within NGINX. And the first one is going to be IP access control lists. And if you use any sort of network firewall or any sort of networking equipment, you should be familiar with the concept of IP access control lists. And you're basically just blocking people based on IP address. So the way you do that within NGINX is using the allow and deny directives. And if you, want to create a whitelist or a blacklist, you can do that both with NGINX. And starting from the top, we have constructed a whitelist here. And so we have a bunch of allow directives, and so we're allowing certain subnets. And you can allow a whole subnet. That's what the first allow directive here does, allow 10.0.0/8, so the entire 10 subnet, or you can allow only a specific IP address. And you can also use IP access control lists in NGINX with IPv6 addresses, which is the third allow directive here. And the final directive, the deny all, is of course what makes it a whitelist. So everything except what we explicitly have stated is going to be blocked. And so we've constructed a whitelist here. The second example on this slide shows how you can construct a blacklist with NGINX. And it's just the reverse logic. So we have an allow all. So by default, we allow everything, and then we explicitly state what we want to deny. And in this case, we're just denying one subnet, 192.0.2/24. You can use the allow and deny directives at the server level as well. And right now in this example, we've put it at the location, but you can put it at the server level if you wanted to apply to everything underneath it. And the access control list directives are also supported for the stream module. And the stream module, if you're not familiar with that, within NGINX is what allows us to reverse proxy, load balance, and provide our functionality for TCP and UDP applications in addition to the standard HTTP support that you're most likely familiar with from NGINX. You can also construct a dynamic IP blacklist with NGINX, and what that means is using our API, and with NGINX Plus, we have an API that allows you to access and modify NGINX configuration using curl or a web browser or any sort of tool sending HTTP commands. And in this case, we're going to construct a blacklist doing that. And so there's a few directives here that we need to pay attention to. And so first off, we have the server block up top. And so the purpose of that server block is to enable the NGINX Plus API. And in this case, we're going to set it to listen to port 1111. You can, of course, have it listen to whatever port you want to do. And then using the previous IP access control list, we're going to block all remote access except for within our current system, in this case, just 127.0.0.1. And of course, you can configure this however you want to, but you do want to, if you're going to use the NGINX Plus API, make sure to restrict remote access because you're effectively opening up an API to modify NGINX configuration. The next thing we do is set the location for the API, and location/API is a pretty good place to put it, but you can put it wherever you want to put it. And the next key directive here is putting API, that actual directive, and then write equals on. And so that means now we specified a read-write API. And so that enables the NGINX Plus API. The next thing that we're going to do is enable our key value store. And so this is what we're going to use to make the dynamic IP blacklist. And so the key is going to be the IP address, and the value is going to be a 1 or 0, whether or not the IP address is banned. So we use the key value zone, the key val zone directive to create the shared memory zone that's going to be used for the key val store. And in this case, we're going to specify it to be a size of 1 megabyte. And then we're going to use a key val directive, and that's what defines the mapping here. And what we're using is money remote address, so the remote address or the IP address of the client, and then mapping that to the value. In this case, we're going to call that band. And then if you look later on in the configuration, we have an if statement, and it says if the band variable is set, we're going to go ahead and return a 403. And so this, and just a couple notes here. So the NGINX Plus API and the key value store is exclusive to NGINX Plus. And you can also use this in conjunction with fail to ban. And fail to ban is a way to manage a blacklist dynamically. And if you're interested in that, you can just search our blog for fail to ban. We have a whole blog just on how to configure this using fail to ban. But if you're going the manual route, so now how do we actually, so we just in the previous slide went through the configuration, how do we configure all this, and now how do we actually use it? And so we use it with curl. So in this first example here, we're doing a simple curl get request to the API endpoint, and that's just going to dump out the key value store, just jump out the blacklist key value store. And in this case, it's empty. So what we're going to do now next is populate it. And so we do a curl request to populate that. And we're pushing, we're going to block, in this case, 10.0.1, set it to 1. So that means now we're going to block that IP address. And if we want to modify it, so we want to unblock it, for example, we just do a curl request as a patch. And we set the value now to null instead of 1. And so now it's unblacklisted or allowed through. We can also remove an IP address from the key value store with a delete request method. And that's the final example here. So that's how you can maintain a dynamic IP blacklist with NGINX Plus. Okay, moving on. One of the most common use cases of NGINX is to offload SSL TLS traffic. So we're going to talk about that in this section. Starting off with Let's Encrypt. And if you're not familiar with Let's Encrypt, what they provide is a free certificate authority. So they can provide you free certificates that are trusted by pretty much 99% of browsers in actual use today. Anything, I believe, after Windows Vista and some version of macOS, I don't recall which, but a fairly older version of macOS. So like I said, most browsers that are actually used today support Let's Encrypt certificates. They're provided for free and they're fully automated. So how do you use NGINX with Let's Encrypt? So the first thing that you want to do is in your configuration, you want to make sure to have a server name directive. And you should have this, just as a best practice, you should always have a server name directive. And the server name just specifies what host names this virtual server is listening to. And in this case, we're going to be listening to example.com and www.example.com. And the reason why it's important to set the server name directive when you're using Let's Encrypt is that's what certbot, which is a Let's Encrypt client, is going to key off of to request certificates for. And so moving on to the next step is to first install certbot. And so we have the instructions here, and it's just basically adding in the repository and then doing an apt-get update, apt-get install python -certbot -nginx, and that's going to install the certbot client. If you're on Red Hat, the instruction is going to be slightly different, but somewhat similar. So if you're using Red Hat, make sure to look up the instructions for that. And so once we've installed certbot, the command is very simple. Just certbot and make sure to put the --nginx. That's what instructs certbot to that we are in fact using NGINX. And by doing so, certbot then will go ahead and automatically reconfigure NGINX with the appropriate configuration, so you don't have to do it manually. And then we have two -d directives, or parameters rather, to certbot. And so those are the domains that we want to request certificates for. And so you see that they match up. We have two -ds for example.com and -d www.example.com, which matches up with the domains that NGINX is listening to in the server name directive. So you go ahead and hit enter, and then there's going to be some negotiation that happens between your actual endpoint, your web server, and the Let's Encrypt certificate authority. And that basically it's going to verify that you in fact own the domain that you're requesting the certificate for. But once it's successful, like I said, certbot will go ahead and configure NGINX for you, so you don't have to actually do any of the SSL configuration yourself. Certbot will manage that for you. The next step then, once you've got the certificates, NGINX is reconfigured, is you want to create a cron job to automatically renew those certificates. Let's Encrypt certificates are valid for only 90 days. And there's a number of reasons why Let's Encrypt does that. Mostly because it's free, and so they don't want people requesting certificates for host names and sitting on it for 2 years, and they don't have the domain anymore, for example. So expiring it after 90 days forces you to check in and show that you still own the domain that you had the certificate for. So we're going to set up a cron, and we just do cron tab -e. And then the next block there shows the actual cron tab command that we're going to put in. It's just calling certbot, that same certbot that we used with the renew -- quiet. -- quiet just tells it not to output anything. And so this cron is going to run once per month. And what certbot is going to do is not going to actually renew the certificate once per month. It's going to then run and see if the certificates are going to expire within 30 days. If not, then it just exits. And if it is going to expire within 30 days, then it goes ahead and attempts to renew it. So that's how this cron is going to work. A few other notes on Let's Encrypt and certbot. Like I mentioned, certbot does all the NGINX configuration for you, and in fact, it also adds in configuration to forcibly redirect all traffic to HTTPS, which is a best practice. And something that you should do for most sites is always encrypt traffic. It also gives you better search ranking, so Google will rank your site higher if it's entirely encrypted. ECC certificates are not yet supported by certbot. It's been on the roadmap for some time, and as of the time of this webinar, they're not supported. I hope it will be at some point, because there's a lot of benefits to elliptic curve cryptography certificates, and we're going to get to those in a little bit. HTTP2 is not supported by certbot, and that means that it's not going to put in the HTTP2 configuration parameter. And we're going to go into how to configure HTTP2 also in a future slide. But you can manually edit the configuration to add that in. So even though certbot does manually, certbot manages the configuration, you can edit it, and it's at least for HTTP2, it's acceptable just to put that keyword in there, so that now you are in fact using HTTP2. Okay, moving forward, that's how you can use Let's Encrypt. And if Let's Encrypt is not something that you want to use and you'd rather manually configure SSL for your site, you can absolutely do that with NGINX. And so this configuration here is basically what Let's Encrypt would or does for you automatically. And stepping through the configuration, the first server block here just does a return 301, so it just redirects all traffic to the next virtual server down, which is the HTTPS encrypted site, so it just forces all traffic to SSL. And then in the next server block, we have a few key directives to pay attention to. One is that we have a listen 443 SSL. And having the SSL there is what instructs NGINX that this is in fact a SSL encrypted virtual server. And then we have the SSL certificate directive. And with that, we specify the public certificate that NGINX is going to use. And then SSL certificate key specifies the corresponding private key. And that's it. And then you reload NGINX, and then you have a SSL encrypted site. You can also use NGINX to encrypt both RSA as well as elliptic curve cryptography. So RSA is the SSL that we're all familiar with, and the majority of websites at the time of this recording run off RSA. ECC has been around for some time, but become more popular lately because what it does is it provides roughly 2 to 3x better performance based on our testing because it has a smaller key size for the same level of privacy. So that makes it very attractive. And so to use ECC with NGINX, what we're going to do is we're going to have now two separate pairs of SSL certificate and SSL certificate key directives. And in this example, the first pair is for the RSA certificate, and the second pair is for the elliptic curve or ECDSA certificate. And so what NGINX is going to do, and why it's dual stack, is that it's going to determine what the client can support. So older clients don't support elliptic curve cryptography. And so for those older clients, NGINX is going to serve the RSA certificate. And for more modern browsers, operating systems that do support ECC, and most do, it's going to serve up the elliptic curve certificate. So in this case, with this configuration, you have full backwards compatibility. So some ways to improve SSL performance with NGINX is using HTTP2 and SSL session caching. HTTP2 is very, very easy to enable within NGINX, and it's just a one-liner. And so that same line here at the very, very top, listen 443 SSL, all we're going to do is add in HTTP2. That's going to enable HTTP2 with NGINX. The next thing is to enable the SSL session cache, and this is going to be storing the SSL session, so the keys and other things that were negotiated as part of the initial SSL handshake. And the initial SSL handshake is actually the most expensive part of the entire encryption lifetime. The rest of encryption, the actual traffic, is done using block encryption, using AES, which does affect performance, but it's not going to be as costly as the handshake. So by having a session cache, we store those parameters of the handshake, so we don't have to keep redoing the handshake for clients. And so we do that with the SSL session cache directive. And in that, we specify the size of the session cache. A 1 megabyte session cache can store about 4,000 sessions. And so we have a 10 megabyte cache. That means 40,000 sessions. And so you want to tune this parameter that's going to be something close to the amount of SSL sessions that you're expecting to have and that you want to actually store in cache. Then we, of course, we have the timeout directive, and that's how long do we want to cache the session for. In this case, we specify 10 minutes. And this is also something that you want to play around with if you have clients that are going to be idle for a very long time. So let's say a client initiates a session, then idles for an hour in your case, and then comes back. You want to set this to an hour so that SSL session that was negotiated before doesn't get renegotiated. And if you don't have long idle clients, you want to set this to a lower bar. And one note on HTTP2 is that it requires OpenSSL 1.02 or greater to work properly. And so that at the time of this recording, Ubuntu 16.04 or later supports HTTP2 and has OpenSSL 1.02. Debian 9 has OpenSSL 1.1.0. And Red Hat 7.4, CentOS 7.4 and later also have the required OpenSSL version. So you want to use those OSs if you're interested in HTTP2. NGINX can also do SSL on the backend to upstream servers. And so, and a lot of people nowadays are favoring that just to protect themselves against pervasive spying. And, let's say that someone breaches your firewall of your corporate data center and then installs a probe. If all your traffic within the data center is open, then that means you can be spied on, and whoever has breached your data center then has a copy of your traffic. But in fact, if you are encrypting everything, then that probe is in effect useless. And so you've protected yourself against a perimeter breach. And so to enable SSL to upstream servers is very, very easy with NGINX. It's just a modification to the proxy pass directive. And so the proxy pass directive, typically you put in HTTP2 if you're not encrypting it, and you just put in HTTPS with the name of your upstream, and NGINX will then encrypt traffic to your upstream servers. NGINX can also be used to authenticate client certificates. And to do that is just a few directives. You have a lot of the standard SSL configuration up top. And then you have the additional SSL client certificate directive, which points to the CA certificate chain that's going to be used to verify that the client certificate is valid. And then you have the SSL verify client directive, and setting this to on enables verification of client certificates. And so if the client does not present a valid certificate, they'll be rejected in this case. You can also set it to optional and combine that with the SSL client verify NGINX variable. And so you can then check using this variable for a particular location. And let's say for some locations you want to verify the client certificate and some you don't. You can then use this variable and go if SSL client verify. And I forget the name of the actual value that says it's valid or not, but you can find that on nginx.org. But you can use that to then selectively block or enforce client certificates for locations and not enforce it for certain locations. Okay, so that's SSL TLS with NGINX. And the next section is on rate, connection, and bandwidth limiting. And so this is, can be used to mitigate some forms of DDoS attack. It's a good way to protect yourself and your applications and not just leave them open to anyone that wants to overload your applications with a bunch of requests or just sending a bunch of connections or downloading a bunch of stuff. First off is rate limiting, and sometimes this is also called request limiting. And they both basically mean the same thing, and this is going to be limiting the rate of HTTP requests that clients are able to make. And there's two key directives here. The first is the limit rec zone directive, and that's what defines the parameters for the rate limit. And so in this case, we're using the IP address of the client using the binary remote adder NGINX variable. And we're setting the rate, in this case, to 10 requests per second. So each unique IP address is going to be limited to 10 requests per second here. Next then is to instantiate that rate limit for a particular location, and we use the limit rec directive to do that. And you see here that we do limit request zone equals my limit. And if you look at the limit rec zone directive above, we have the zone equals my limit. It also has a :10M. That means the size of the shared memory region to reserve for request limiting. And so going back to the limit rec directive, we have the zones. We can link it to the limit rec zone or directive above. So now anything going to /login, each unique IP address can be limited to 10 requests per second. And then we have the burst equals 10 and no delay parameters. And so stepping back a little bit, when we specify a rate of 10 requests per second here, what we're effectively doing is allowing one request every 0.1 seconds. I believe that's the correct math. So let's say we get 10 requests all within that first 0.1 second. What's going to happen, NGINX is going to allow, without the burst and no delay parameters, just one of those requests through, and the rest will get dropped. And for most cases, that's probably not what you want. And so now we want to specify basically a queue. And so in this case now we specify 10, a burst equals 10 and no delay. And so now what's going to happen is we're going to get those same 10 requests in that 0.1 second window. Because we have the burst there, that first request will go through and the remaining 9 will also be allowed through with no delay. And then the rate limit will be enforced for the rest of the time slice. It's recommended to use the burst and no delay parameters for most deployments because having a delay, for example, if you have a queue and you just allow one request per time slice is probably not what you're expecting and will just introduce latency. So you always want to make sure that the requests are sent through with no delay. If you're interested in rate limiting, we have a whole webinar just on this subject. It goes into each detail, different things you can do with it. If you just go to nginx.com/webinars, you'll find that particular webinar. You can also limit connections with NGINX, and the configuration is very, very similar to request limiting here. And so we have the limit con zone directive, just like the limit rec zone directive, and that's where we define the parameters of the request limit, or sorry, the connection limit. In this case, we're also limiting by IP address. One key difference is we don't actually specify the connection limit in the zone directive. We specify it in limit con. And so with the limit con directive under /download, we're instantiating a connection limit for this particular location. And we're specifying 1 here. So that means that each unique IP address is allowed 1 connection to this location. You can also use NGINX to limit connections to backend servers, and that's using the max cons parameter, and that's going up to the top of the configuration here. And you can specify the maximum number of connections NGINX is allowed to make to an upstream server. And in this case, 50 connections is the most that will be allowed. If you're familiar with the stream module, we're also connection limiting is also supported for that. And finally, bandwidth limiting. And so this just limits the amount of bandwidth a client can use to download files from your server. And there's 2 key directives here. The first is limit rate, and that just specifies the overall bandwidth limit per connection that a client can have. So in this case, it's 20 kilobytes per second. The limit rate after says to impose the limit only after a specified amount of data has been downloaded. So in this case, we can say that the first 500 kilobytes of data, there's no limit. Then after that, we limit it to 20K. And so you'd want to use the 2 in conjunction just so you can fill the, have some buffer in there for the client. So you send a lot of traffic up front, and then you start trickling it out afterward. For the stream module, for TCP and UDP traffic, you're going to use the proxy download rate and proxy upload rate directives. And they're configured in a very similar manner to limit rate and limit rate after here. Okay, moving on to authentication. And NGINX supports 3 methods, 3 ways to authenticate users. The first is HTTP basic authentication. And that is installed or used with NGINX in conjunction with a third-party tool called HTPassword. So the first thing that you want to do if you want to do HTTP basic authentication with NGINX is to install this package. It's part of Apache 2-utils. You're going to go ahead and install the Apache 2-utils package. And once you do that, you'll have the HTPassword utility. And using the HTPassword utility, you're going to specify do -c to create the file, and then you specify the actual file that you want to use. In this case, we're going to put in the etc NGINX directory where all our NGINX configuration lives, and it's a good place to put this password file. And in this case, we're just going to name it .htpassword. The next thing is the user that we want to create within this password file, and I've just put user1, but you're going to put the actual users that you want NGINX to validate. So you press enter, then it's going to prompt you for the password for that user. Then it's going to go ahead and create the file with that user and his password. And for each successive user that you want to put into this file, you're going to go ahead and just rerun that same command with just changing that last parameter. It doesn't store the password in the clear. It just stores an MD5 of the password by default. And there's different, you can look at the man page for it, but the best way I think is just to use the MD5 password. And so the file format, if you look at it, is just going to be username, colon, and then the MD5 hash of the password for each user. Okay, so now that we've created the actual file, we can move forward and configure NGINX for basic authentication. And the 2 directives here are auth basic, and that specifies the realm and what's going to be prompted, what the user is going to see when they see the dialog box to enter the username and password. And then the auth basic user file is going to reference the file that we just created. So that's telling NGINX what password file to use. And so that is how you enable basic authentication with NGINX. The next is sub-request authentication. And so this is slightly more complex than basic authentication. But it's, let's say within your organization, you have an LDAP server or even just a homegrown authentication server, and you want NGINX to query that before allowing users through to an application. Using our sub-request authentication module, you can do that. The key directive is auth request. So for whatever location that you want to have NGINX initiate an authentication subrequest, you can put auth request and then the location that you want to do. In this case, it's going to be an internal NGINX location. You always want it to be an internal NGINX location because there's a few other things that you need to do. But looking forward, we then have the internal location. And by saying internal, that means that only NGINX itself can access this location. So no one outside can access this particular location. Then the next step is going to be to proxy pass to the authentication server. And that's actually not the authentication server itself. We'll get back to that in just a second. It's going to be actually some intermediary. And then we're going to go ahead and clear the content length and set the original URI and the X original URI header. And so the way NGINX is going to process the sub-request authentication is that if the sub-request results in a 200 OK, that means that this user is going to be allowed through, and if not, the user is going to be blocked. So taking it back to LDAP, and let's use LDAP as an example. LDAP doesn't speak HTTP, it speaks LDAP. And so what you're going to need to do is write some intermediary code that will take in the request from NGINX, turn around and create the LDAP request, check if it's successful, and then return a 200 OK if so, and I believe a 403 if not. For LDAP, if you go to our GitHub, we have a sample implementation on how you can build that intermediary converter between HTTP and LDAP. For other authentication services, for example, your homegrown authentication server, if you have one, you'll need to create that code yourself to convert whatever language your authentication server speaks to standard HTTP that NGINX can understand. So the sub-request authentication module is, I think, is a very powerful tool to link NGINX to pretty much any authentication system that you may have within your organization. Moving forward, and the second to last topic actually for this webinar is going to be using JSON Web Tokens and how you can use NGINX Plus to authenticate users based on JSON Web Tokens, typically pronounced JWT and spelled JWT for short. So how do JWTs work in a nutshell? So the first thing that is going to happen in the workflow is that the user is going to request a token, and we'll get into how the token looks in the next slide, but just assume there's some sort of token here. So the client's going to request a token, and there's going to be some issuing authority, and that can be a homegrown issuer, or it can be something like Google or Okta or an identity and access management provider that can issue these tokens, and most of them are capable of doing so. But the client requests a JWT from some issuer. The issuer then is going to validate the client and make sure that he is in fact a valid client. And if he is, then he's going to go ahead and issue the client a JWT. And the client then is going to turn around and send that to NGINX Plus. NGINX is going to validate the JWT. And if it is valid, it's going to allow the user through. And optionally, it can parse the JWT for you and pass the relevant fields to the upstream services, in this case, an API endpoint, as standard HTTP headers. And just a note before we continue that JWT authentication is exclusive to NGINX Plus. So that's how JWTs work in a nutshell. So what's inside of the token? And the token itself can be split into two main parts. The first set of brackets here, in this example, JWT is the header. And the second is the payload. Starting with the header, we specify the type. And the next field, which is important, is the algorithm that is used to sign this. So all JWTs are signed. That's how they are prevented from being tampered with, and how NGINX validates that it's in fact a valid token. And so in this case, we specify that this token is signed with a SHA-256 hash MAC. We support multiple signing algorithms as well with NGINX Plus. The next is the key ID field, and that's what links it to the signing key. And so the ID field here is going to be linked to the same, a similar ID field within the signing key. The second set of brackets is the payload, and this is what defines the user. And so we have the name field, which is the full name of the client. And then the subfield, which is the unique identifier for the client. In a lot of cases, this is just going to be an email address. We have an expiration date, and then we have an issuer, which is just a text of who issued it. And if you're accepting JOTs from multiple issuers and third parties, it's useful to have that so you can parse through where the JOT came from. The final JOT itself is base 64 encoded, and that's the second block here that has multiple colors. So the green portion of it is just the signed base 64 encoded header portion of the clear text JOT above it. And the next is the payload portion. And then the third field is the actual hash map. So how do you configure NGINX to validate JOTs? And there's a few key directives here. First is auth JOT. And if you're just think back to the HTTP basic example here, it's very, very similar in terms of configuration. And where we had auth basic before, but now we have auth JOT, which enables JOT authentication for this context and defines the realm. There's an optional token parameter. By default, the JOT is sent in the authorization header as a bearer token. And that's what NGINX by default will look for it. If that's not the case for your application, or for whatever reason you want to put it somewhere else, you're more than welcome to do so. And you can use the token field to specify where exactly it is. Next then is a pointer to the key file. And so for each issuer is going to have a JSON web key file. And that is going to be the public certificate that NGINX is going to use to verify that the JOT is valid. And of course, there's a private key associated with it that sits on the issuer. And you don't need that on NGINX because it just needs a public key to verify it. So the issuer is going to use a private key to sign it. And then NGINX is going to use a public key here, the JSON web key, to verify that the JOT is valid. All JOT claims are put into variables with the format here on the third bullet point, JOT underscore claim, and then the name of the claim. So JOT claim sub, for example, here is what we're using. And so we're going to put this into a header, and we can put the header whatever we want. In this case, we're just calling it API client, but it can just be, for example, username or user ID, and then you put JOT claim sub, and then that is going to be passed in a header to the upstream server. You can do that for the name field or any field within the JOT. So a slightly more complex example here is a nested JOT claim. And this is something that we just added support for in NGINX Plus R14. And there's a lot that can be used, you can use nested JOT claims for, but the main thing that it's used for is for authorization. And if you look at this JOT, there's a groups array below. And so when the issuer issues a JOT, it can also issue the groups that the user is a member of. And in this case, this user is a member of 3 groups, but the key one that we're going to focus on for this example is administrator. So how can we use this to do authorization? And looking through this slightly more complex example, what we're going to do here is we're going to use some more directives. The auth JOT claim set directive is going to be used with NGINX to pull out that array and convert it to an NGINX variable, JOT groups. And then moving down, we're going to use a map directives. So we're going to basically look through this list of groups that the user is a member of. And if it contains administrator, we're going to set the isAdmin variable to 1. And if not, it's going to be set to 0. Looking down, we have a location block near the bottom of the configuration sample, location/admin. And you see here we have an if directive. So if isAdmin is 0, so the group user is not a member of the administrator group, he's not going to be allowed access to this particular location. So using the group data and nested JOT claims and array data, we have performed use NGINX to authorize a user to a location. In this case, if the user is not a member of the administrator group, he is denied access. Okay, and the last thing it's not related to JOT or any of the other subjects, but it is security related, so I wanted to put it in here, is NTLM proxying. And if you are using NTLM within your organization, that's mostly used for Microsoft, you need to use the NTLM keyword when you're defining the upstream servers that are relying on NTLM. And this instructs NGINX to maintain keep alive connections to the upstream servers so that requests from different users are not interleaved on the same connection. NGINX will interleave requests across connections as a way of optimizing the flow of traffic between NGINX and upstream servers, but that's a violation of the NTLM protocol. So by specifying the NTLM directive, NGINX will not do that. And another note, NTLM proxying is exclusive to NGINX Plus. Okay, and so before we get to the Q&A, I'm just going to summarize what we talked about. So we started off the webinar with talking about NGINX IP access control list, and that's a very standard way of just blocking users by IP address. If you know someone is being malicious and you know their IP address, you can just straight out block their IP address, and a very common way of protecting your site. TLS offload is commonly used with NGINX, and we have a nice integration with Let's Encrypt, so you can use NGINX along with Let's Encrypt to get free certificates and automatically renew those certificates. We have rate, connection, and bandwidth limiting to help mitigate some forms of DDoS, as well as limit download speed for users. We support multiple methods of authentication with NGINX, the standard HTTP basic authentication, and also sub-request authentication that can be used to link to LDAP and other authentication services that you may have within your organization. And of course, NGINX Plus supports JOT authentication to restrict access to APIs, perform single sign-on. And this support is exclusive to NGINX Plus. All right, and that takes us to the Q&A.
Okay, great, Faisal. Let me start with a question that occurred to me as you were going through the different NGINX options. Do the steps that you outlined here overlap at all with what people use a WAF for? And what does a WAF do that these steps can't accomplish?
All right, cool. Thanks, Floyd. Pretty good question there. So a WAF is typically used to protect against layer 7 attacks. That's going to be your SQL injection attacks, your remote file include, and attacks that are aimed at exploiting bugs and poor logic within backend application servers. And so that kind of goes above and beyond what we discussed here. What we discussed here is using NGINX really to restrict access to your application and perform some levels of DDoS mitigation. So most likely you're going to be using some forms of both. And so you'll be using a WAF to protect your application logic, and then NGINX as your gateway to restrict who can and cannot access your application.
So they're almost entirely complementary.
Yeah, I would say so.
Okay, great. We have a lot of good questions here. I think a lot of them are quite specific, so I'm going to go through them in kind of machine gun fashion here. First question is, if we're using Stream, how do you determine the outside address so you can use the ACL?
Just as you would with HTTP, your IP header is the same, whether it's TCP or HTTP. So you just look at, you can just use a TCP dump, for example, or whatever tool it is that you use to gain visibility, find out the IP address, and then you would just use the same exact directives to block the malicious users.
Okay, great. Does it matter where you place the deny all? Can it be put on top of the allow IPS?
Great question. I believe it doesn't matter. NGINX configuration is not order dependent. It's not a programming language that's dependent on order, so you can put it anywhere.
Yes, that's right. That's generally true. Can you use NGINX in the .NET Core framework? And if yes, does it support Windows 2016 Server? How to configure your virtual application path similar in IIS in NGINX? Let me take a shot at this one and then bring Faisal on to really get at the detail level. I think that NGINX is more often used as a reverse proxy in front of .NET and Windows servers. There is a Windows version of NGINX, but it doesn't have the same performance as the other versions and isn't widely used. Is that about right?
Yeah, you would just use NGINX as your reverse proxy to your .NET application.
I have a default NGINX installed, and I built another one using PageSpeed. How do I remove the default NGINX, or at least point to my NGINX to be the new default?
Okay, so actually what you're going to do in this case is you're going to what you should do, what I would recommend to do is use our builds, and that was the prerequisites portion of the slide. So you want to make sure to use the official NGINX builds, and rather than compile NGINX with PageSpeed, you can compile PageSpeed as a dynamic module. And I believe specifically with PageSpeed on our blog, we have an example of how you can do that. So you can compile PageSpeed as a dynamically loadable module, and then load that into the official build of NGINX. And that's the way you want to go about that.
Okay, great. And I think I recognize this name. I've seen the same questioner before. Will certbot on renewal reset my SSL configuration like HTTP2?
It should not. So that's why I put that in there, in that particular portion of the config is not going to be affected by a certbot renew. So you're safe to put HTTP2 in there and then just save the configuration, and then really just certbot, the only thing it's going to do is just replace the certificates. So after the initial configuration, I don't believe it even modifies NGINX config. So it's safe to put the HTTP2 in there.
Okay, great questions. We're going to go right to the hour. So if you have a question, send it in. Can we have two different web servers in Windows 2016, such as IIS and NGINX? In this case, IIS used default AD port, and can I change the port number in NGINX? I think, again, this is a case where you use NGINX as a reverse proxy in front of IIS, but let me check that with Faisal.
Yeah, that's correct.
Doesn't that cron tab line run the job at 12 o'clock every day rather than on the 12th day of the month? Somebody's proofreading your configuration code.
That shouldn't be the case, and we did test it. So I'll go back and talk to who wrote that. I think it's going to run it on the. It should run it once per month. That was the intent. If there's a typo there, we'll correct it. So I'll have to go and further investigate that.
Thank you for the heads up. Wildcard Let's Encrypt certifications are in beta. Is that correct?
I don't know if it's in beta, but I do believe they're actually going to support that. They, for a long time, said that they were not going to support wildcards, and it seems like that is in fact something that they are going to support. So yeah, stay tuned.
That'll be useful in a lot of situations, including microservices, right?
Yeah, I mean, you just have the star, so you just have star, and you have a single certificate for your entire domain, so you can add new domains fairly easily. So it's a lot of additional functionality you'll get with wildcards.
Okay, cool. And Let's Encrypt free certificates are particularly important with microservices because instances can be born and die all the time, so you don't want to be paying for your certificates there. Key directives that should be included: limiting the protocol to TLS 1.2 and ciphers to those that are more mature. So that sounds more like a statement than a question.
Yeah, it's a good suggestion, and yeah, maybe something could have covered in this webinar, and definitely a good topic for our future webinar is how to use NGINX to harden your security rather than just going through the security features like we did here.
Okay, great. Thanks for the suggestion from the questioner. With HTTP2, there are gotcha blacklisted ciphers to avoid, and then it says Mozilla SSL TLS config builder. Faisal, your reaction to that?
Yeah, I mean, I know that HTTP2 restricts a lot of the older, less secure ciphers. I'm not familiar with the SSL TLS config builder, but that's definitely a good point to bring up.
So the questioner is recommending that to all and sundry. Does NGINX support third-party SSL certificates?
Yeah, I mean, any valid SSL certificate is going to be supported by NGINX. That's Let's Encrypt or whoever you want to use.
Is the proxy redirect off semicolon required at the end of the reverse proxy statement?
I'm not sure what that's referring to. So I can't provide a good answer.
Did you
there.
see this string in the config that you were showing?
It might have been in there. I'm not.
Okay.
So like I said, I'm not remembering it offhand. So I apologize to the questioner, but I can't provide an answer to this one.
Okay. I read that it's better to use low rate per second and higher burst for optimum performance. Is that true?
I wouldn't say it's better or worse. It's really dependent on your application, and I think, if you're going to use rate limiting, you're going to definitely, it's going to be an experimental thing. So you're going to try some limit and see how it works. And if your application is very bursty and you get a lot of burst and then a lot of quiet, that may actually work out better. But like I said, it's heavily dependent on your application.
Okay, cool. It looks like we have just the right number of questions to answer for the amount of time we have left. Let's see. For example, 100 requests per second and 200 bursts with no delays. Sorry,
yeah, that seems like and the rate limit and the burst are not too far off. So that just off the top of my head seems like a valid config.
I have an NGINX server using SSL with a self-signed certificate. Do I need to take any additional steps or remove that in order to switch to Let's Encrypt and Certbot?
You would just remove all that configuration. So you'd remove the SSL certificate key directive, and just strip down the configuration to what I had on that slide, and then allow Let's Encrypt to do the configuration for you. Right. So that's what you would do.
Is the request dropped or responded to with a 429 response code?
And I believe this is with the request limiting, and I believe it's a 429. I forget the exact response code. But if you go to our blog and you search rate limiting, or if you watch that rate limiting webinar that I referred to, we go through what the response code is, and you can actually substitute a different response code if you want as well.
Are all NGINX Plus exclusive features specified in the slides? So any slide without specification is available in the community version, right? I can say that the slides only give an overview, and that our website lists the features in a general way. Specific features, I think you actually have to look at the, is that on the website, or do you have to actually look at the documentation?
No, so yeah, so I'll answer both parts of that. So the slides that I actually presented, that everything that's not, that it explicitly says as NGINX Plus exclusive is available in open source. And then if you go to our website, like Floyd said, if you go to the product section, NGINX, under NGINX will list all the features, and it's clearly demarcated what's in open source and what's in Plus.
Can a location block have multiple rate limiting directives? For instance, limiting to 10 requests per second and 50 refs per minute?
I believe that's possible, and that's something that's actually covered, that type of advanced configuration in that rate limiting webinar, as well as in the rate limiting blog that we have on our website. So to look to that, and like I said, I believe so, but I don't fully recall, so I can't give a definitive answer.
And just to be clear, that rate limiting webinar is available for our download on our website at www.nginx.com/resources. And you can specify webinars, and it'll pop right up. And this webinar will be recorded and sent out to all of you in the next 24 hours or so. We use CA single sign-on. To know NGINX supports CA SSO, so they're wanting to know whether NGINX supports CA SSO and whether it overwrites SSO authentication with NGINX authentication, and then HTTP basic ?
Okay, so that's like, do we support CA SiteMinder? And I believe we do. I know we were doing some work on that, so unfortunately, I can't provide a definitive answer there. But I would just say look at our blog, and we should have something on that front at some point.
That's also a question I think you could get answered by calling sales to check with the SE.
As well, yeah.
Yeah,
so
if that specific situation. Job provider is also from NGINX Plus, or can we use custom, meaning, I think, can you do it in open source, or do you need Plus for a job?
that may be the question, but I think what he's actually saying is who issues the JOT. Is that NGINX Plus? And no, NGINX Plus doesn't issue the JOT. We just validate it, but you have a third-party issuer, and that can be a homegrown solution. So you just there's some libraries online, I forget what they are, and you would just build your issue around that, or you can use Okta or OneLogin or any of these IAM providers that also issue JOTs.
Okay, we're going to need to finish up. There's still a few questions, so we're going to somewhat stay after. So the live part of the webinar will stop, but if you stay online with the webinar and have asked a question, we'll send out the Q&A we'll send out these last few questions and answers to everybody. So stay online if you're interested in some of the remaining questions. Should just take us about 5 minutes to give brief answers to them. All right, thank you, everybody. Really enjoyed doing the webinar, and thanks for your participation. It's been great.
Yeah, thanks, everyone.
Thank you again for joining us. Our previous webinars are available on demand on our website, nginx.com, in the resource section, so be sure to check those out, and have a great day.